Record. It should say recording starting now. Thumbs up. Okay. Well, welcome this morning. My name is Larissa Johnson. I am the Residential Energy Program Manager for Montgomery County Department of Environmental Protection. And I'm really excited to bring this program to you this morning because, like you, I am also interested in how to electrify my home as much as I can. And so I do not have an electric heat pump. I know, bad Larissa, but hopefully after hearing from Jim today, I'll learn all the things that I need to know about how to go electric. And you will see some fun furry friends in the background, and I apologize for that. All right, so on the line right now, we have Ana Ariaza from Department of Environmental Protection. She is here in case anyone would like to have anything translated into Spanish or has any questions. If that is something you are interested in, please just let us know in the chat. She will be here participating as we all are, but also here to help with any translations that may be needed.
Buenos días, mi nombre es Ana Arriaza, estoy acá hoy por si alguien necesita ayuda en español. Por favor, podemos platicar usted y yo directamente o lo pueden poner en el chat. Así que aquí estamos para ayudar. Aquí estoy para ayudar.
Thank you, Ana. Yes, and Ana is a employee of Montgomery County Department of Environmental Protection. She is our partnership coordinator. So we are so lucky to have her here this morning. Additionally, we have Jim Conlin, or James Conlin, as you can see on your screen. And he is our expert, y'all. I just talk about how we can electrify and why we electrify, but I do not know the specifics. So I had to make sure that I brought in someone for you all to answer your questions. And just a reminder that the month of October is Energy Action Month, and this month we are focusing on electrify everything. And every week it's a different focus. This week is on electrify your home. That's why we're talking about heat pumps. And the link is in the chat. If you have any questions or want to know what else is happening, you can find more on My Green Montgomery. And if you have any questions throughout the presentation, please place them in the chat and Jim will get to them either during his presentation or at the end. The other thing too, if you are looking for transcripts, live transcripts, if you go to the bottom of your screen, there is a little box that says CC live transcript, and it will auto populate for you. Questions, comments? Welcome, welcome, welcome. We are so glad you are here. I am going to turn it over to Jim to introduce himself, because no one does it better than the person themselves.
Good morning, everybody. Thank you very much, Larissa. I'm happy to be with you all today. And I really enjoy what I do, which is talking about all sorts of stuff, but heat pumps are some of my favorites, and they're gaining a lot of currency, especially recently. And I'll get into that a little bit later. But I want you to all know that I appreciate your time. And just to sort of set the agenda for us, it's a pretty simple agenda. I want to introduce heat pumps in their context, which is one system in a broader sort of collection of systems which really make up your house. So we're going to go through house as a system. You can read the rest. We'll do a little deeper diving on heat pumps. I'm going to use a case study to sort of bring to life, if you will, a lot of the concepts I'm going to touch on. In one of the hats I wear at my company, which is called Elysian Energy, I do trainings. I do trainings both for internal staff as well as third-party staff. I'm credentialed by the Building Performance Institute to do so. I only say that to sort of warn you that I might get really technical. If that happens, both Larissa and folks in the chat, please put in questions to help me clarify, because my intention is to give a very broad audience a really great introduction to heat pumps, and there are a lot of rabbit holes I can dive down, and I need to make sure that I don't do that. So help keep me honest on that. And then you can read the rest of the stuff. There will be plenty of time for questions. I've prepared a few answers to questions I get a lot, and then I hope to see some questions in the chat box, and we'll really make it more of a conversation. And I'll come back to that idea. As someone who might be in a position to purchase a new heat pump, one of the recommendations I have is to find a contractor you're comfortable having a conversation with about what your needs are and what your goals are and so forth. But first things first, I started Elysian Energy in 2007. The mission of Elysian Energy is to provide data-driven recommendations based on that conversation. Our vision is enhancing the built environment for a more sustainable future. My academic background's in biology, and so the idea of the home being, the modern shelter is exactly, is a real one. So that translates very well. And then a lot of the ways I understand heat pumps and sort of the, science application, applied to your home is really through that lens of biology, of a system, interactions, ecology. And so you might hear me say that or refer to sort of analogies in that way or metaphors using that sort of imagery. Any technical jargon, again, I apologize. But the FAQs, the case study, we'll have time for Q&A, like I said. And then I also have a list of additional resources. So for those of you who have an appetite for really technical information, you'll get that, but you'll get it as additional reading. 1 hour with Q&A, we can't do a deep dive on the heat pumps, although I will explain the science at a higher level. To begin, you really need to think of your house as a system, right? So the heat pump is, or that your heating and cooling systems generally are abbreviated with the term HVAC, which stands for heating, ventilation, and air conditioning. You may also see some contractors saying they're HVACR contractors. The R stands for refrigeration, and usually that refers to a commercial or industrial application. And so for residential purposes, I'm gonna use the term HVAC quite a bit for that general term of making your space warm in the winter, maybe cool in the summer. But there are other systems in play, right? You have electrical systems, plumbing. Another system that is not totally static, but you don't really think about it too much. It doesn't really move, is what we call the envelope. And the envelope of your home is really the components that keep the heat in during the winter and the heat out during the summer. In layperson's terms, what I mean by that is, they're your walls, they're your top floor ceiling that hopefully both of those are insulated. They're your slab if you have a slab on grade house, or if you have a crawl space, it would be that floor, between the crawl space and your kitchen, for example. And same goes for, cantilevered spaces, rooms over the garage, all that sort of stuff. The reason that's so important is that the envelope really informs what sort of heating equipment size you need, so that you're not putting in, a Mack truck engine into your house and paying for it, frankly, when really what you need is, a Corolla engine to get you where you need to be to comfort your home, or to condition your home for comfort. When I look at this stuff every day, the envelope is taken for granted, and a lot of the other systems are too. And when you get into the code books, and I got to be careful here because you can do real deep dives on this, but they often defer to manufacturers' recommendations. So they'll say, do it this way, or manufacturers' recommendations. And manufacturers' recommendations, in my opinion, and I am guilty of this just as a homeowner or consumer, are often overlooked. They might say change your air filter every month, for example. I don't do that. I usually do it about every other month, once a quarter at least. And that's really important because there's wear and tear involved with your home and all their independent systems, right? So your lights go out, your lights burn out. Your HVAC system should get tuned up. Insulation can settle. We just recently experienced a tenant in our attic who was a squirrel and was ripping up insulation, which then impacts the envelope of our home, and we lose a little bit more heat there. So my point is not that you have squirrels in your home, but that there are a whole host of things going on. An additional example that is actually outside the home, I was walking my dog the other day, and I noticed my neighbor's, probably 50-foot tall evergreen in his front yard, which his home faces south, so it provides a lot of shade, had died, and it was just across the line in the county property. So somebody from the county had came and tagged it, right, for taking it down. And as I was walking by, the first thing that I thought of as an energy geek was, oh, that's going to change the solar load on that guy's house. There's going to be less shade, so a little less cooling. So his cooling load is going up. He's going to need to run his AC a little bit more. And he may actually get a little bit of a heating benefit in the winter because he's going to have a little more solar gain. So my point is not to totally geek out on this. My point is really to help you understand that when you're really taking a good look at heat pumps, it serves you very well to step back and look at the broader picture that your house is a system. So what is a heat pump? You all are familiar with heat pumps. Heat pump in a general term is some appliance, some machine that literally moves heat around. And they usually convey the heat using a refrigerant. So your refrigerator is a heat pump. It pulls heat out of the refrigerator proper and ejects it outside of the refrigerator. So depending on how it does that, you might have warm feet. I had a fridge a few years ago where I was like, why is the floor in front of the fridge always warm? So that's where the discharge heat went. They had a fan that blew it from underneath. In terms of our conversation here, we're really talking about air source heat pumps, which are the heat pumps that are most commonly referred to. When I hear someone at a contractor or a home builder's trade show, and they say, oh, we're talking about heat pumps, that's sort of what I default to, right? There's a box outside, there's an air handler inside, and they communicate. And so your air conditioner, if you have central air conditioning, is what I call or what people in our industry call a unidirectional heat pump, right? It's a heat pump that takes heat from inside your home through a refrigerant and through some chemistry and through some really changing the pressure of those refrigerants, because changing the pressure changes the phase. That's where the magic happens with the energy transfer. So for folks wanting to do a deeper dive on the thermodynamics involved with that, please know in the resources section, there is I'll refer to an organization called NEAP, which I think stands for Northeast Energy Partnership. They are a very credible organization and they do a lot of really deep dives. So if you're here because you really want to know the thermodynamics of the refrigeration cycle, that is where I will point you. For the rest of us, I want to just introduce this heat pump. Okay, fridge, sure, got it, fella. To, okay, now we're getting into central air conditioning. That's a heat pump, right? And that does one way. What I'm going to focus on now, what I really want you all to know about is that today's heat pumps, and I'll get into a little more specifics as we go, they're really efficient at bringing in heat from outside, even when it's really cold. And it's not intuitive, right? But if you go outside when your AC is running and you actually put your hand over the top of the big fan on top of the outside unit, it tends to be warmer than the outside air. So you're 90 degrees outside on a hot day, your AC is running, you put your hand on it, it's even hotter. And so it really sort of goes against one of the laws of the second law of thermodynamics, which is, to summarize this idea of equilibrium. Nature really likes equilibrium. So if you're trying to get that out of balance, you got to add some energy input. And so heat pumps magic is really in that ability to take a little bit of electricity, change the refrigerant in a very functional way to provide comfort, right? Taking the heat out in the summer, which we enjoy as cooler air, and then bringing heat in during the winter, which we would then enjoy as warmer air. So the AC is one form. Here's a picture of the heat pump I was just talking about. So what we're looking at with this slide is, for a technical term or folks who might be having a visit from an HVAC contractor later today, what this is called a split system, right? So there's an outside unit and an inside unit, and that they're split from each other as opposed to a packaged system. So a window AC would be a packaged unidirectional heat pump. Real jargony right now, I promise it'll get less so. So the heat pump bringing air back, or the heat back in, even when it's really cold, is the magic of the heat pump. And I'm going to focus on one particular type of heat pump, but I thought it would be beneficial to just sort of start with a case study. So I'm going to use my own home as an example. And the long-term goal for me is I'm in the process of converting my home from using electricity, for lights and motors and, Wi-Fi, how I'm able to speak to you all right now, in addition to natural gas. And we use natural gas with 3 appliances: our range, our domestic water heater, and our furnaces. And I want to get rid of them. I'm not in a hurry. Our furnaces aren't that old. Our water heater is. And our range, I just don't like, because I've done a bunch of reading on it, and there's a resource I'll refer to in due course that I read about. I said, you know what, I don't want to risk it. So my goal is to have a home that is very efficient. And I'm starting with my envelope first, right? Remember, that's the sort of insulation and draft stopping, so that we're sort of separating my interior environment from the outside environment. Homes that are really drafty, the way a building scientist looks at that is says, oh, well, you have too much involuntary air exchange, right? That's a very sort of diplomatic way of saying your home's drafty, wear socks in the winter, your feet are going to be cold, right? In addition to that, it's worth knowing that doing that sort of improvement has a couple of really positive effects. Just in and of themselves, insulation and air sealing are cheaper than HVAC improvements. And the second is they have a knock-on effect, and this is the system interaction impact of changing what your load is, or how much heating or cooling your systems need to provide for you to feel comfortable. And you tell your system how, you interact with your system to some degree in terms of telling it how comfortable you want to be by way of your thermostat. So that's how you say, I want it warmer, work a little harder, want it colder, work a little harder if it's the summer. And that's all a big deal. And they have impacts. So that when I work on, if I add insulation in my attic, it's going to change the demand on my HVAC systems. Another one that's sort of low-hanging fruit, in my opinion, is to do a lighting retrofit. Modern lighting options include light-emitting diodes, shorthand is LEDs, and those generate much less heat than a traditional incandescent light bulb, and even less heat than a compact fluorescent lamp. And so when we were running incandescent light bulbs that were 60 watts, over 50 watts of that was actually being generated into heat. So actually, they're little heaters, is not an ungenerous way to think of that. So I did that. And then the one appliance that I want to change, and I'm not a fan of getting rid of perfectly functioning equipment, that's sort of goes against my, minimize waste sort of ethos. But we have a gas range and oven. We've got stovetop, oven, and as part of my day job, we test for carbon monoxide all the time. And in ovens, in particular, ranges, the stovetops are harder to test. It's not that as a building scientist, I don't care about it. It's just, frankly, it's just really hard to test. I don't have a good gadget to test that. How well your stovetop is combusting the gas. And when it has incomplete combustion, that's where you get carbon monoxide, oxides of nitrogen, oxides of sulfur. All that stuff is not good for you. And common symptoms when it's really low level exposures are like, I feel a little off. I have a little bit of a headache. Maybe I have a little bit of nausea or lost my appetite, and all that's avoidable. And so that is the one piece of equipment that I'm going to change proactively. And that's really more of an indoor sort of a health issue more than an energy efficiency one. So I don't want to get too far lost on that, but I do want to point out the fact that there's, an interaction. And my philosophy that underpins all of this is that the built environment, right, buildings, or in the residential sector, it's, homes, apartments, condos, they must serve their occupants without harming them, right? And then ideally it's, okay, yeah, I've got comfort. So when we walk into a house, it's, okay, first, do no harm, health, safety, durability. Is there mold? Is there biological growth somewhere else? Is there a plumbing leak? Is there a sagging ceiling because there was a water damage from, some point in the home's history? And so, it all matters, I guess. And then once I sort of tighten up, my home, make sure it's nice and efficient, I do what I can. Then at that point, I really like the idea of a heat pump, because the heat pump, because then that becomes all electric. Once my home's all electric with solar panels and a battery storage system, I have my own power plant. And in terms of someone who is a small business owner, that's a big deal for me to be, who works from home, and obviously not only just COVID, but as we're, returning to work, my company no longer works in the office 5 days a week. We work 5 days a week, but I'm in the office 2-3 days a week. And then everything else, when I'm doing my, office work, it's usually at home. And that's really important. And I know I'm not alone. I'm sure there are people on this call with other reasons, folks with medical needs that, with electrified, medical equipment, it's a no-brainer. I mean, this is just and in fact, even though it's expensive and I expect costs to come down, and there are a whole bunch of incentives that I'll talk about in a little bit, rolling out in 2023, people have been doing this, making this decision for 15 years. I started Elysian Energy in 2007, and people were doing it before I started. And so that's sort of the holy grail is saying, okay, my home's pretty well insulated, and it's the load is what it is. I'm going to get a right-sized piece of equipment. When I call the HVAC contractor and call multiple, and again, I have a resource about questions to ask and sort of how to vet contractors. I got to say one thing, in my own experience, that be very leery of the lowest cost, not because lowest cost is worse, but in terms of peace of mind, I would strongly encourage you to put some value on your peace of mind, whether that's, okay, my neighbor recommended somebody very highly, but I didn't get a good feeling. Maybe it's a different project manager. Maybe their staff is turned over. So, what I'd strongly advise when you're pursuing a heat pump and all these considerations is to make sure you're taking care of yourself, number one, that you're being taken care of. Because if you get someone who says, oh, this is how we do it, maybe it's what they have on their truck. I went to specify some equipment for a project the other day. And I was like, great, I want this stuff, where is it? What store, what shop do I have to pick it up from? And I was like, oh, that's a 60-day back order. And so another best practice that is in the resources is to start early with this stuff and be planful about it. Because when your AC or when your system fails, when it's 99 degrees outside and real swampy, you're going to get emergency pricing. And that's, I'm not proud of that, but emergency pricing happens for all sorts of really valid reasons. And so if you need somebody to come out, Saturday night, you're going to pay Saturday night prices. So being, ahead of the game and doing this research, and, so many people in Montgomery County are such prudent consumers of information, like folks like you on this call on a Saturday morning. So I feel confident that folks on this call, if you're watching this, at a later date, please consider this a process, and doing your research on the front end is much better. The analogy I use is that, if you're going to do some surgery on your home or do a major renovation, you usually get the diagnosis first and then make sure it works for you. And so I have a few more tips on that. So for me, my furnaces aren't that old. And to replace them, people, I suspect, and this is an FAQ I'll get to in a little bit, it would cost me a lot of money to replace them. And so I'm not eager to do that until I need to. They're also already high efficiency, and they're operating well. So they're not giving me problems. I don't have, I can do my own work. I'm a licensed journeyman HVAC license holder. So I can tinker with that stuff on my own, so I can save my own money there. Annual or biannual, semi-annual maintenance is generally recommended between, maybe in the spring for the cooling season and then the fall for the heating season, just to sort of clean them up. It's usually just it's an inspection. It's more of like a physical, and then maybe we replace some components that have a little bit of wear and tear, and just make sure they're operating as designed. That's also in the manufacturer's, sort of maintenance or owner's recommendations. We'll have, frequent, at least annual, if not semi-annual maintenance on the stuff, just to keep it clean and operating. Make sure there's not any damage, or again, the wear and tear, or, pest came in there or something happened when you weren't looking at it, some surprise. So, however, when those furnaces start giving me problems in several years, I already know what I'm going with. And it's called a cold climate air source heat pump. And this sort of lends itself to some of the FAQs. And so for the FAQs, this is what I get all the time. Many people on this call have these questions. So here are the answers. Do air source heat pumps work in our climate? Yes, absolutely. There are a couple different types, actually several different types of air source heat pumps. And most homes use what's just simply known as an air source heat pump. in that sort of split configuration, outside unit, inside unit. And again, it's, taking heat from the air, bringing it inside when it's cold, outside, seasonally. And more specifically, I recommend the cold climate air source heat pump for a few reasons. Historically, and in fact, I have a visual guide that is not on the screen, but I'm going to leave it there. But I actually went through my textbook to see what do they say, how do they describe an air source heat pump, and they define it pretty loosely. It's not quite as technical as I was expecting in terms of the thermodynamics. But they even say that the authors of this book throw in the caveat that historically these systems do not work well in cold climates. And the climate that we live in Maryland is what's known as a mixed humid climate. Mixed meaning hot in the summer, cold in the winter, versus a cold climate. So New England is, historically, New England's a cold climate, where AC is opening, air conditioning in the summer is usually an open window, right? So we have the mixed, hot summers, cold winters, but then we also have the reality of living in a humid climate, and humidity is something we need to manage, because if you have too much humidity inside, one, it's less comfortable. Humans are pretty sensitive to humidity, so managing that is a factor in HVAC design. But it also, moisture tends to beget, biological growth. Mold is sort of the big one that we've all sort of seen to some degree. And mold can be really bad. I'm not here to be alarmist about mold. However, as someone who suffered physically from mold exposure, as well as a mycotoxin, which is a fancy word for the poison that certain molds produce, mold thrives in a humid environment. So if the interior of your home is consistently 70% relative humidity, for the nerds out there, for the geeks out there, or higher, you have the potential to create, that's basically what's going to create a mold potential. And so mold, humidity is a big deal as well. But in our climate, historically, the heat pumps would need a little bit of extra juice, electricity, literally, to meet the load on really cold days. Cold climate air source heat pumps remove that through advances in engineering as well as manufacturing. These cold climate air source heat pumps can deliver full heating load capacity down to 5 degrees Fahrenheit. Just to make sure I wasn't selling snake oil here, I went into the guts of some of the software I use for HVAC design to actually look at the data. And in Maryland, in terms of design temperatures, we are at 5 degrees Fahrenheit for 12 hours a year or fewer, and that is based on 30-year averages. I looked more recently just to see, okay, what's it been like the last few years? And I looked at 2019 and 2020 using, I believe it was the College Park College Park Airport weather data. And in 2019, we got down to 7 degrees Fahrenheit for an hour. Or pardon me, that was the lowest temperature. That didn't tell me for how many hours, but I'm sure it was overnight for a couple hours at most. And then in 2020, we got down to 14 degrees. That was the coldest we got that year. So the cold climate air source heat pumps being able to deliver full heating capacity down to 5 degrees Fahrenheit is legit for our climate. And so I want to disabuse that myth that because some contractors are still using my textbook note saying, yeah, they don't always work everywhere. Historically, where air source heat pumps would work great, I use Richmond, Virginia as sort of the demarcation line for that, where if you had an air source heat pump there or farther south, it should be working for you just fine the whole time. When it goes colder than that, those air source heat pumps still harvest heat. They just don't harvest heat enough. They don't harvest enough heat to meet the load when it's really cold out. So your home would be adding heat from the air source heat pump, but not at the rate it wouldn't, but the rate that it was losing heat would be greater. With cold climate air source heat pumps, that is not the case. To get full heat down to 5 degrees Fahrenheit is great. I'm originally from Chicago, and I've been really surprised by that because it does get down to 5 degrees Fahrenheit and below that in Chicago. where Chicago is known as what's, that's a straight up cold climate. Even though the summers can get okay there, it just gets too cold to, so you design around the cold because it's that extreme. I just want to make sure I'm getting, what kind of heat pump do you recommend? Spoiler alert, cold climate air source heat pump. Are they more expensive? I apologize for the typo, that's going to drive me nuts. Are they more expensive to buy? Yeah, probably a little bit. If you're just looking apples to apples, which is to say, the standard, what they have in stock versus what my client has to wait 60 days for. Yeah, the initial cost, just apples to apples, sort of boxes to boxes, which we use in the industry. We're going to swap boxes. They're a little more expensive. However, when you have an air source heat pump, one of the things that you have to account for, and this is really relevant for folks who may be considering fuel switching like me, is that the electrical panel, the electrical service that you get through the distribution network, from Pepco's, linemen, the folks who, installed it in the home to begin with, those panels often, typical home, when I go into a, 1,500 to, 4,000 square foot home, I expect to see a 200 amp panel. And all that means like a basic panel, big gray box, bunch of, sort of like black light switches that are horizontal. Those are circuit breakers. And you need to have space on your panel. You need to have, there's a certain amount, there's a maximum amount of electricity that you can pull through that panel. And for the circuit that needs to be dedicated for a heat pump or your AC or your furnace, it needs to be big enough because the startup power required for heat pumps is pretty big. And so if you're switching from a furnace to this added electrical demand, you may need to upgrade your panel. So if you're getting if you have a, quote unquote, regular standard issue air source heat pump currently, you probably have a bunch of electric resistance, what we call backup or strip heat. And that is literally the same technology as a toaster. And so the cold climate air source heat pump does not require that. In most cases, I should say, will not require a panel upgrade if you're going from air source heat pump to cold climate air source heat pump. If you're fuel switching, you might. And so box to box, they're a little more expensive. And then maybe if you need electrical work, that's going to add some costs. And I don't want to sugarcoat that because it's, it's a real world cost. What I would add to that is, for my purposes, there's a value to me on switching, right? And it's not solely economic. The range I'd mentioned is really, that's an indoor environmental quality issue. I got 3 little kids, 2, 5, and 7. And the Rocky Mountain Institute, which is the resource I referred to at the end of the slide deck, they did some research, and it's a very data-driven nonprofit. They did some research and said, oh yeah, in fact, that combustion inside your house is exhaust, and we're breathing it. So natural gas burns pretty cleanly. It doesn't burn perfectly cleanly. So let's see, number 4, are they more expensive to operate? No, they're not. They're super efficient. And I mean that both for other air source heat pumps, which you can get in various levels of efficiency. The manufacturers want to sell you their product. So they have good, better, best products. And so they have the stuff they can make that is sort of usually legal minimums. Department of Energy or code might say, okay, we're here now, y'all. Let's make these, let's have some minimum efficiency because we can. And it's important for resource preservation, preserving for later. National defense, all this stuff, it's all related. When you step out and really look super big picture. I also compared recently the operation of a very high efficiency cold climate air source heat pump and a top of the line efficiency gas furnace, and it was really close. To be explicit, and honesty is my top value to a fault, I've been told. The natural gas furnace, using today's commodity costs, was slightly more efficient. I think it was about 8% more efficient for a roughly 2,000 square foot home with a pretty traditional construction type for Montgomery County sort of area. It's also worth noting that depending on your home, if you have a beautiful old home like I used to live in, that was built in 1923, it had a masonry wall, big double brick wall, versus the home I moved into, which is more traditionally built these days, which, 2x4 framing members and drywall interiors and so forth, that all matters. So there's everything that I'm saying right now needs to have an asterisk next to it, because no home is identical. Like the two homes built in the same production build, same tract, they may very well operate quite differently depending on how they were installed. Because if you have different crews out doing the work when they're under construction, because we do new construction advisement as well, I know they work differently because I run diagnostics on those tests, on those houses, how they're maintained. And then just, oh yeah, one of them had a tree branch fall on them, the other one didn't. The other one had storm damage, the other one didn't. And so, and I see Larissa's raising her hand. Do you have a question, Larissa?
Yes, because there's a few things in the chat that I want to address because we're here on the facts and it depends. So Carol, who I do know, hi Carol, has a dilemma. So they need a new HVAC, pretty urgent, not in a position to upgrade leaky envelope now. The house was built in 1950, complicated by a leaky addition, not to current R value code. The only people she knows who are satisfied with heat pumps have well insulated homes. Others say it is useless below 32 degrees. Would it keep up with our cooling needs in the summer? And would new cold climate heat pumps really keep up with our heating? That's the dilemma.
Yes. So Carol, I'm sorry about your sequencing, because I understand, you got to put out the fire in front of you first. So I completely understand that. So the cold climate air source heat pumps totally will work. They will meet your heating demand. They will meet your cooling demand. What you need, there are two sort of units of measurement or efficiency ratings that you need to pay attention to with any air source heat pump. They are heating season performance factor. That basically tells you how well it's going to work. It's a gradient, but the idea is that the higher number, the better. And typically what we recommend for really high performance is 9.5 or higher. You might see 9.2, 8.5. Those are all really good. And I guarantee you they are probably 25 to maybe 50% more efficient than what you would see from an existing system that might be, your system might be 10, 15, 20 years old. If it was, well maintained and well installed firstly, and then well maintained. In terms of your summer cooling demand, absolutely. Those same systems, remember, they just sort of work in reverse. It's the same boxes that have to be really efficient to pull in that cool air or the heat while the air is cold, pull in the heat from the cold air. That's the same system. It's the same heat transfer, surface area, the fins that literally pull it back out. So what you want to, the number that you want to pay attention to is called the SEER rating, which stands for Seasonal Energy Efficiency Ratio. And again, you're going for a higher number. So HSPF and SEER are two categories. So don't compare, this, HSPF's 9.5, only 9.5, and the SEER, but the SEER is already 10. That must mean it's better. No, it doesn't. It's easier to pull in air conditioning because the temperature gradient isn't that great. The engineering needs to be a lot harder for pulling in heating in our climate, because if you like your house at 70 degrees and it's 90 degrees, that's 20 degrees difference, right? If you like your house at 70 degrees and it's 30 degrees out, that's 40 degrees difference. And so the physics has to be able to, make that leap, if you will. I would be remiss if I didn't say, this is going a little bit out of order, but in the resources slide that I'll get to in a little bit, there's a PEPCO program called the Home Performance Program. There's a no-cost program called the Quick Home Energy Checkup, and that's something you can call on if you need a new heat pump this weekend or in the next week. This is probably not going to help you, but the Quick Home Energy Checkup program is a way to get somebody out at no additional cost to you. There's already a surcharge on everybody's bill that goes into this pool of funds to create a whole real big pool of benefits that people can tap into, rebates, incentives through the utility company. And that funding mechanism, if you're looking at the bill, is called the Empower Maryland Energy Efficiency Act of 2008. And it's a surcharge. And people pay $1 or $2, and it's one of the taxes that goes into this that you go to pay your bill. those funds go to the state redistributes them back through these programs, so through various programs. And the first program is called the Quick Home Energy Check. That's no additional cost. I can't say free because you're paying for it on your bill, but that's a way to get sort of an inspection. People will take a look at your home and see if there might be bigger, it's a way to get a trained energy auditor out to take a look. The deeper dive is called the Home Performance Program. Pepco will underwrite the cost of most of that. They still need to they want you to have a little skin in the game. So it's called usually $100 to get started. If you have a really big home or multiple systems, companies can elect to choose a little more than that. I know ours does because it takes more time and it's harder. And my sons just came home. So I guarantee you are going to be introduced to my 2, 5, and 7-year-olds. So, so that's going to happen. And here's Jack. And that looks really cool. I'm talking to some friend. I can't do this right now. Can I talk to you in a little bit, please?
Okay.
Thank you. I'm blushing. So there we go.
Hi, Jack.
And then Jack and Liam, or Seamus and Liam will be in a second. And my dog's in the way of the door, so I'm gonna have to kick her out too. There we go. But the home performance program is really important for a couple of reasons. The main one is that one, it's a deeper dive. There are 2 reasons: deeper dive, but then secondly, it opens up access to more rebates to take care of insulation, air sealing, and the sealing of the rebates for HVAC. You can get 2 different ways. One is just a straight HVAC rebate. Your HVAC contractor should know that. The Pepco website will have a list of HVAC contractors who are familiar with their programs to help you with paperwork. The home performance program is what's based on what's called a performance-based incentive. So depending on how much energy efficiency or electricity, kW, kilowatt hours, and kilowatts, which is a power thing that's folks who know utility economics are paying attention to, that can save you more money. But if you're in a hurry, the biggest benefit I have for you today is at the end of these, there's a resource that I will connect you to that's put out by NEEP, and it's a consumer's buying guide. And so it has way more questions than I have for you guys. I put together about a dozen questions that I would recommend. I would tell my brother to ask a contractor back in Chicago. And then I saw their guide and I was like, oh, this is so much better and elegant than what I'm doing. Is there another question, Larissa? Or I think
There was another one there, and I put it on the last slide of your slide deck, but
oh, cool.
it
Okay.
is, yeah, I think we answered all of them almost, except for this one. It says, oh, wait, sorry. I'm just gonna go here. Can a heat pump be used with a radiator heat system?
Yes, yeah, it can. I've been focusing on what are known as air-to-air, air source heat pumps. There is another technology called air-to-water. And so it literally does, so instead of harvesting the heat from outside, bringing it back inside through refrigerant lines to a box that has a blower motor over the heat exchanger. And a heat exchanger is, just you run refrigerant. There's usually a bunch of little either fins or little spikes or something to just increase the surface area for heat transfer. And then the blower just blows air over that, and it picks up heat as it goes, and then it goes through your duct system and out. Same exact thing, but instead of air blowing over the heat exchanger, there's a pump pushing the water, usually over the same type of heat exchanger or similar strategy anyway, over the heat exchanger. That water then gets pumped and delivered to the radiators. Radiators warm up, and you enjoy it. So yes, it's absolutely possible. They're less. It's a little bit more of a specialty. So you may need to call around a little bit more to folks who do that, and you may need a plumber to help connect some stuff as well. Just because usually when you're talking about hydronic systems, plumbers often are and folks who are very familiar with boilers, that is something you'd want to vet pretty thoroughly to make sure that you're not wasting your time or theirs, frankly, but they're really efficient. There are 2 other types of heat pumps that I haven't spoken to, and they're worth noting. Very similar to what you just said, in that you take it from air, put it to water. There's another type of technology called the ground source heat pump. And that is where we literally drill wells or excavate a big chunk of earth and then put down tubing into the earth, because when you go down, it depends on where you're at, but roughly anywhere on the planet, once you drill down about 10 feet, it's in the 50s. And that can change seasonally to some degree, and it will certainly change as you're using your heat pump. But the idea there is that if you live out in the country and you can dig up some land and you bury these coils, it's basically an energy bank, right? So it starts pretty cool. Well, let's say it's 10 degrees outside and you've drilled down 10 feet and it's 50 degrees. Your heat pump on the inside actually still only has to change, work as hard to make the 50-degree incoming water temperature to 7 degrees over a heat exchanger. So there's still an electric component to that. And if anybody has more questions about that, please contact me offline. Ground source heat pumps are really cool. They don't go in everywhere. They're not as easy to install for everybody. So I haven't sort of specialized that or spent a lot of time on it. The other thing that is a really effective air source heat pump is called a mini split. And so it's still a split system. It's just really small. And these are the sorts of things that are extremely popular. And if you've been to the Far East, Japan, Korea, really it doesn't dominate, but they have a really big market share of heat pumps all over Europe, South America. You see these things everywhere. I'm starting to see them in newly constructed hotels here, but what they tend to look like, and there are a number of different technologies, what I think of a mini split, it's usually a wall mounted, box, maybe about 3-4 feet long, and it sort of sticks out from a wall somewhere. They sort of stick it up anywhere. Those things are super efficient. They're even more efficient than some of the cold climate air source heat pumps. And those are usually for points, what we call point source distribution. So you put an addition on and you don't want to tap into your big central system. Ductwork is expensive. It's labor intensive. Somebody's gonna have to make some holes in your drywall and painting and yada, yada. So they're great solutions for home offices, great solutions for the additions, as I mentioned. You can also get a mini split that has multiple heads, and that can be a great solution for condos, apartments. I'm actually considering one for my own home because there are 2 areas of our home that we congregate in a lot, and I don't need to be conditioning the rest of my home when I'm in my home office, for example. And those mini splits are, to a machine, really efficient. It's impossible. I have not seen an inefficient mini split that was well installed. If there's something going wrong with a mini split, it's usually a installation issue or operations maintenance needed to be cleaned and it wasn't. Something got clogged. My kids were playing. Jack was throwing a baseball at it. So those are 2 of the things I'd be remiss if I didn't mention, but I didn't want to focus on that because the air source heat pumps, and more specifically the cold climate air source heat pumps, are an excellent solution for electrification, which is why I have the pleasure of being here today. So let's see, in terms of resources. Oh, I'm sorry.
More resources, 2 more quick questions that I don't know if they're fully answered, but what is the status of heat pump refrigerants? Because you started talking about that. Which ones are being discontinued and which are the most environmentally friendly?
Yeah, so this is a great question because historically, the refrigerants that really tore a hole through the ozone layer in the 80s for other dinosaurs like me. I'm a child of the 70s, and that used to be young and hip, and now it is not. I'm finding by talking to my nieces and nephews. But the old refrigerants were chlorofluorocarbons, and they react with the ozone, which is a triatomic oxygen molecule that is produced all the time, usually over 1 million times a day globally by lightning strikes. And so when we cut out CFCs, the ozone layer repaired itself. So that when I believe, and I'm sorry, I could look up in my book. I want to say it was R22, and I'm misremembering because what we mostly see now and have been seeing for the last maybe 10 years is a new refrigerant called R410A. And what that refrigerant is it's a cousin that doesn't deplete the ozone layer quite as much. And actually, I don't know if it depletes the ozone layer at all. And I need to know that, so I will look that up. That is further getting replaced with, I believe it's called R23. And so that is not currently being mandated. That is happening in the next year or two, where new systems will require that. And then they have some sunset time horizon so that installers and techs can access those refrigerants. And whoever asked that question, please contact me. My email's at the end. I'd be happy to do a deeper dive and get you the really specific questions on that. Something to keep in mind, however, is that those refrigerants, I've really stayed away from this because it's really technical, but the material properties of those refrigerants is what makes the machines work. So you cannot use any refrigerant in any system. It has to be specific to what was engineered and manufactured. So, and so for example, R4, the CFC stuff was great because it was so reactive, right? So machines could be pretty small, which is great if you're trying to fit a bunch on an apartment building, or you're trying to, free up yard space for playing, or for, nobody likes, walking around a house on a purchase, a home inspection, and being like, oh, I really appreciate that really big outside, condensing unit outside for an air conditioner. The R410A requires a little more surface area. It's not as volatile, and that's a good thing, globally speaking.
Awesome. Two more. So one is, and you talked about it a little bit about the electrical panel upgrades, but someone was asking what actually needs to happen. I think you mentioned that there's not necessarily an electrical panel upgrade that has to happen, but when would they need to know?
Yeah, so your HVAC contractor will have to have this knowledge. So if you are not comfortable opening up your electric panel, don't. That said, if you're unsure about what happens when you open the electric panel, literally nothing. You kind of slide over a little tab, you open it up, and you're going to look at a series of black circuit breakers. They're little light switches that sort of are sideways, that do a lot more than light switches, by the way. They are not light switches, for the record. However, that panel is going to be rated for some amount of amperage, and literally the panel is manufactured by somebody, GE for example. They say, okay, here's a 100 amp panel. Here's a 200 amp panel. What we see in new construction, or in most homes these days that aren't, that are built in the last few decades, is a 200 amp panel. And so what that means is that those, let's say 20 circuit breakers might be rated for 10, 15, 20 amps each. Well, for an air conditioning system, one of those boxes, a heat pump box, even the blower motor associated with a furnace, those should all be on pretty big dedicated circuits. They're usually, it depends on exactly how they're wired, but they're 30, 40, 50 amps. What we're putting in it's a 4-unit apartment building, but it's about the size of a pretty good sized house. We're putting in a 60 amp service. And so what that means is that when that thing fires up, it requires a lot of power so that all of the electrical equipment works as designed. And so if you starve it of the electricity it needs to start, it won't work. It's as simple as that. So what we're finding, and in fact, this is baked into the Inflation Reduction Act. I've been screaming it at everybody who will listen, that when we're talking about heat pumps, electrification, and using greenhouse gases as a metric, and trying to how to incentivize that, the electrical panel upgrades, there is money being set aside for that, because there will certainly be certain homes that need a major electrical overhaul if they're planning to get really convert fully to electrification. For my own home, which has a 200 amp service, I've got 2 AC furnace systems, 2 sort of central systems, one for our top floor, another for our basement and first floor. I have enough open circuits. I have 60 amps available on my own home. So what I'm gonna have to pay an electrician to come out and basically reconfigure it, because the circuits aren't they're not adjacent. And sometimes the way that you get a 40 amp circuit in is it doesn't replace one light switch circuit breaker, it replaces 2 circuit breakers. And so it's literally a double that sort of slaps into 2, and then it has to be wired appropriately. I'm not a licensed electrician. I do light wiring, but I am not I could not pull a permit for that part of the project. So I will absolutely defer to my brothers and sisters in a different trade of the electric trade. So and that cost, I mean, the other thing, just to answer an unasked question, what's that going to cost? It depends. Right now, if you'd asked me this a couple of years ago, I said, $600, maybe you can get a deal a little bit lower if it's, if it's a smaller service. Higher than that if it's more amps, because it's usually more juice, a little more dangerous, more equipment, more wires, more circuits potentially. So I'm seeing, because electricians are so busy, that price might be double, triple, quadruple that to put in those panels. So it's not cheap. And if people are on this call to take away that, oh, this is the initial cost is going to be so much cheaper, I am not saying that. What I am saying is, and this is on the resource page, and Larissa, can I flip forward? I want to make sure everybody gets it. In terms of resources, PEPCO, there's the program I mentioned earlier called the Quick Home Energy Checkup. You're already paying for it. It's no cost, in addition to the assessment you get. And it's not comprehensive. It's a sort of not 30,000 foot view. It's like a 3,000 foot view of what's going on in your home. And an assessor should be able to look and say, oh, okay, you've got 3 inches of insulation in your attic. You would benefit from 8, 10 more inches of insulation. Oh, hey, I saw some exposed wires. Hey, I saw some mold. Maybe you want to consider an exhaust fan in your bathroom downstairs that nobody ever uses. Stuff like that, high level. The PEPCO also has that home performance program. It's $100 to do a deeper dive in terms of diagnostics. Opens up access to a bunch of rebates, up to $7,500 in rebates, which is quite a bit. And then I'm a big fan of DEP. I'm not just saying that. I've been working with Department of Environmental Protection since 2007 in one way or another. And for those of us who may not be from Montgomery County, in terms of recruitment, they have a comedy of riches. Their talent pool is very enviable. If I could hire as well as Montgomery County from the same talent pool, I would. NEEP, which I have at number 3, is a nonprofit based in New England. They are awesome. And on the next page, I have links to their consumer. It's actually a technical resource page, both for contractors. So if there are any contractors, a person who asked me about refrigerants might be able to learn a thing or two from their technical resources for contractors there. They also have an awesome consumers buying guide. And I reviewed, and they have some videos on YouTube that I reviewed last night in prep for this meeting that were fantastic. Rewiring America is a relatively new nonprofit. They have published a couple of really important things. One is a how-to book, or really a guide that's about 100 pages long. I used it personally for my own home, and I use it professionally because there are resources in there that I learned from. And that the Rewiring America is rewiringamerica.org. And they also have, in terms of rebates, they have put together an excellent calculator for projecting potential savings based on an incentives from the Inflation Reduction Act. That is a really big deal. And then the Inflation Reduction Act, there is a nonprofit I trust called the ACEEE or ACEEE.org. They put out a policy brief on the Inflation Reduction Act that basically took that mammoth act and distilled it down into 3 or 4 sort of bite-sized pages. And they include a very readable and very accessible table for all the stuff that's available through the Inflation Reduction Act. And I think I'm remiss because the last website, which I didn't put on there, and Larissa, hopefully we can put another one on there. If you want to look at every rebate and incentive policy, for homeowners to industry to agriculture to you name it, NC State gets funds to host an awesome website called the Database for State Incentives for Renewable Energy.org. It's dsire.org. Don't put an extra E in there. I've never done it. I don't want you to either, but it's dsire.org. And when I was there the other day, I put in 20850, HQ's zip code, and there were 77 different programs to parse through. I would look at the residential ones, and then in addition to that, the PEPCO programs, and that is really pretty comprehensive at this point.
Awesome. All right. So We have just 2 more questions, Jim, and I just want to make sure we are answering them. This PowerPoint and the presentation will be on our website for mygreenmontgomery.org. It will be listed under the Electrify Your Home page, which is in the chat. And I put Jim's contact information in the chat as well. I know some folks may have to leave. It is the top of the hour. It's 12 o'clock. It's 12:02, but I just want to make sure these 2 questions are answered. And yes, if you are, the last website was mentioned was Desire. Let me make sure we have the right one.
I did add it to the chat.
Oh, look at that. He already added it.
Yeah.
So it's, oh, you sent it to me. That's okay.
Sorry.
That's all right. There it is. Okay, so the last 2 questions, Jim, are, okay. One is, would mini splits be the solution for a second story that stays too warm in a home with an open staircase? Are they still very expensive?
Mini splits may be a solution. Typically, when we have that thermocline, there are 2 primary issues related to that. The first is related to air sealing and insulation. Like if your attic has a foot of fiberglass or cellulose insulation, that is my 2-year-old trying to break in. That's where I would start, because insulation and air sealing are cheaper, compared to doing an HVAC retrofit. So your mini split, let's say your upstairs is, you have a nice, beautiful sort of entryway, atrium, and then you have, a master and an office up there, and you're worried about your master. Yeah, a mini split would probably take care of that. If it's a little bigger than that, what we find with that sort of separation or thermocline, the stratification, you may have a return side issue with your ductwork. That's getting a little nerdy, but that would be the other thing I would want to check. Mini splits may be the solution. For 1 room, I would count on $3,000 to $6,000 for a mini split. And then the out of pocket, and then their operating cost is very small. I mean, it might add, $10 per month that you're using it. So if it's really just well, I don't know if that happens in the heating or cooling season, that'd be another follow-on question for your contractor, for your energy auditor, if you go through the home performance program.
And this is a great segue, because as I mentioned before, this is just the week that we're talking about electrifying your home, specifically on heat pumps. Next week, we will be focusing on induction cooktops and stoves. So we will be doing a food demonstration at Crossroads Farmers Market on October 19th at 10:30 a.m. It is a Wednesday, but we will be there doing a food demonstration using the induction cooktop. And if you have questions about induction cooktops, that's a great opportunity for you to come and ask. We'll have information there. But the question here, and this is very specific, but would more slots be needed in the electrical panel if you're going from a gas stove to an induction stove?
Probably. Yeah, I mean, yeah, probably is I would count on it if I were you. Yeah. Right, yeah, I mean, just to, so in my case, when I looked at it, we have 60 amps available. The range, which is not just a cooktop, so cooktop may be a little different, a little better. But so my experience was with the with the whole range, and we needed, the county requires, I think, 50. And when I talked to an electrician, he'd recommend, no, put 60 in there. You don't want to, if you have something else, or somebody had done something with the existing circuit, sort of behind a wall, they recommended it. We had it. The other thing, in terms of putting in a sub panel, it's not major surgery. It's doable, and it's, if you're talking about $1,000, $2,000, it's way less than a roof. It's way less than an HVAC replacement. So in terms of just incorporating it as part of that sort of cost of doing business, it's easy for me to write checks with somebody else's checkbook, right? But the way I think of it is that if you're trying to value engineer a decision, please include other things that that are important to you. And one of the questions, people may want to consider that can make access to that sort of thought process available is, if you had a magic wand, how would you want your home to be, right? And so for me, during COVID, I went from being in the office 5 days or being in the field 5 days to being at home 7 days, right? And so my home became way more of a sanctuary. My home became a much bigger deal. For those of you who are working from home, I would strongly recommend going to your HR department and saying, hey, y'all, you all put quite a bit of your capital costs on me, right? So like payroll's number one, rent is probably up there in terms of their, CFOs, budgeting, controller, bookkeeper. They know what they're paying for that and they know what they're saving on it. So I would strongly encourage, and here's the other thing, the labor market's loosening up a little bit. It's still really tight. And especially around here, it's tight. Believe me, I'm trying to hire and it's hard. And so in terms of being an attractive employer, we have a program where we actually go to employers and say, hi, we know what happened with your square footage demand and your bills, because that's sort of what we do all the time. We calculate energy efficiency for commercial spaces on a per square foot basis. It tends to be pretty reliable in many ways, and they're listening. So bug them and then tell them to bug me, and I will come up with a program. But I don't know, was that on the mark, or did I drift too much there?
I think that was great. And I know that one of the things that hasn't been promoted yet, but there is a pilot happening in Montgomery County coming up specifically to help people that are income qualifying switch to electrification. So that is happening, and you can find more on our website, of course, when that is updated. But for those that have any other questions, you can always email Jim, and that email is right there on the screen. It is also in the chat. And as I mentioned, the PDF of this will be put on the website, as will the recording. But I think you nailed it, Jim. Thank you, thank you, thank you. I also believe that if people have questions, they can email you. They feel comfortable emailing you. And for those that are watching this later, again, please email us. You can either email Jim or myself at energy@montgomerycountymd.gov. Thank you. And that is it. All right, I'm going to stop my recording now.